Hi, my name is Paul Mattingly, and the research paper that I will be discussing today covers the reactive polymer epoxy. This research paper is about manufacturing bio-inspired materials and using ultrasound to direct self-assembly in the 3D printing process. So what this paper is really concerned with is figuring out how to incorporate ultrasound frequencies in the 3D printing process to better align fibers in a matrix of the photopolymer resin, which is epoxy. For this paper, the experimental approach used a traditional FDM process, or 3D printing, that uses a liquid photopolymer resin that has microfibers of NCCF embedded in it, or nickel-coated carbon fibers. And what the experiment was really looking for was how to better align these fibers within the liquid polymer resin. So they looked at how introducing ultrasound frequencies during the process could help better align these materials, and also the effects of the print speed on the overall result as far as mechanical properties and electrical properties. The first study from this experiment looked at how introducing the photopolymer resin to ultrasound frequencies during the 3D printing process would affect the alignment of the nickel-coated carbon fibers within the polymer. So the results of this experiment showed that during the process, when they did introduce ultrasound frequency to it, it did improve the alignment of the nickel-coated carbon fibers. And as the frequency of this ultrasound energy increased, it actually increased the density and better aligned the carbon fibers. So the key takeaway from this is really that self-aligning materials within a polymer resin is possible, and ultrasound frequency is a great way to go about this. And it also allows us to 3D print these bio-inspired materials in single layers. The first study of this experiment also looked at how changing the weight percent of the carbon fibers within the resin would change the properties of the material, and looked at how it would affect alignment. And it really didn't have much effect on mechanical properties at all, but increasing the weight percent of the microfibers did make it more difficult to get them to align properly. Study 2 looked at the effects of the 3D print speed on these nickel-coated carbon fibers. The key result from this study showed that increasing the print speed actually decreased the clarity of the aligned nickel-coated carbon fibers. And this was mainly because it decreased the density of these fibers within the polymer resin, resulting in it making it harder to align and decreased mechanical and electrical properties. So the reason this happens is because with the increase of print speed, you need a higher flow rate. So with the higher flow rate, the material is less able to absorb the ultrasound frequencies. So it makes it difficult for these carbon fibers to align with the same frequency compared to a lower print speed. The good news is that the ultrasound frequency does increase its density, so we can somewhat counteract the effects of an increased print speed, but there is a limit, because as your ultrasound frequencies increase, you also introduce more thermal energy into the system. So there is an upper limit to how much energy we can actually put in, and how much of these print speed effects of lowering the density we can actually counteract. The key results from this paper is that through the introduction of ultrasound energy, we are actually able to 3D print in single layers a bio-inspired material that has self-aligning fibers. And the ultrasound energy actually allows us to increase the alignment and the density of these fibers, which increases all kinds of mechanical and electrical properties of the material. Another key conclusion is that the print speed actually decreases this density and makes it harder to align these fibers, but a lot of this can be overcome through the introduction of this ultrasound energy. And another key conclusion is that changing the weight percent or the amount of the microfibers within the polymer really has no effect on a lot of properties. It's the alignment of the fibers is much more important.